Let me help you guys recall what we did in the last class. And I think Vishal was there, Praneeth could not join, but Praneeth would have watched the video of the class for sure. And here comes Samriddhi. Samriddhi, how are you now? I know you were not well before.
I'm good.
You good now? Good. So in the last class, we started the unit called Conic section. And that is where I was literally messing up with all of you, playing with piece of paper, cutting it into different shapes, and then trying to believe what a conic section means to us and how do we see that there is a relationship between a circle, an ellipse, a hyperbola. They are all coming from conic section. Basically, when you slice a conic section in different ways. Lok, Chita, Avijay. So in the last class we talked about what is a conic section and how these shapes, circle, ellipse, hyperbola, everything comes by slicing or dicing a cone, be it one cone or two cones. And we tried establishing the relationship between a circle and an ellipse. How is a circle an extension of an ellipse? That's what we talked about. So we'll just touch upon that little bit and then we'll jump into dealing with all the interesting properties of ellipse, because circle you guys have dealt with enough. So I'm not going to go to circles as part of this unit, but we'll talk about all the interesting things that we need to know about ellipse. Okay. Everybody able to recall, right, what we talked about? Yeah? Okay. Vishal, Achita, Vijay, everybody, right? Okay. And do you guys, so again, I keep on requesting you guys to keep your video on because that makes me very comfortable, but I don't know, you guys don't feel comfortable, is it? See, my only request would be, see if you can come with a mental preparedness to keep your video on it, okay? Because that I would say that actually helps, because that establishes a better connection between the teacher and the student, okay? It helps me communicate with you guys more effectively. Okay? I know it's not easy. You guys being tired whole day with a lot of classes, lot of homework, lot of activities, but yeah. I would really feel very happy if I see you guys turning your video on, okay? Not today, maybe next class, maybe after 2 classes, maybe after 4 weeks. I'll wait for that, okay? Okay, so let's move on. So what I was saying was, there's a relationship between circle and ellipse. And I'm kind of going back to convincing ourselves that a circle is another form of ellipse. Now if I, hey Dave. So here, if I try relating that, if you look at circle, the properties that we know is, it has a center and each and every point on this center is equidistant from each and every point on the perimeter of the circle. So you have only one radius everywhere. Where in case of ellipse, you have two varieties of radius. One is called the major radius and one is called the minor radius. So where you see this being wider, where the radius is bigger, this is given as the major axis, and this distance from here to here is called the major radius. Similarly, this is called the minor axis, where you see a smaller value. This is called minor axis, and this distance is called minor radius. So here you have, let's say this is A along the x-axis and B along the y-axis. So basically you have minor radius and major radius. So if you try squeezing this a little bit, so that it becomes like a circle, meaning you squeeze it so much so that your minor and major radius become the same. That is when you end up getting a circle. So let's look at the equation for the ellipse that we saw in the previous class. X squared by a squared plus y squared by b squared equal to 1. And the circle of equation. And again, here in this case, we are assuming that center of the circle is coinciding with the origin, and the center of this ellipse is also coinciding with the origin of the coordinate plane. So in that case, my equation is x squared plus y squared equal to r squared, or x squared by r squared plus y squared by r squared equal to 1. So I will delete this equation because this guy is creating some confusion. This was the source, but I have one-to-one comparison here. So in this case, what we are seeing is when your minor and major radius becomes same, and we can give it one common name as r, that is when circle is born. So essentially, if I have to establish a parent-child relationship here, I would treat this as a parent, this is a child. Because this is more generic in nature, this is a customized version of it, where both the radiuses are matching, meaning you are squeezing it so much so that your minor and major radius are same. You come across a circle. Is that okay? Samriddhi, Vishal, Arush, everybody okay? Akshita is not sounding convinced. Are you okay, beta?
Yeah, I am. I'm just out right now. So.
No, I understand. See, again, problem is not with you guys. Problem is with me. I have, again, with age, you become more and more skeptic. You start doubting people. You start assuming that people are not even paying attention to you. Okay, I'm just kidding. So what I'm saying here is, again, it's for me to get the confidence. Okay, so if I'm calling out your names, it's not that I'm doubting you guys. I'm just trying to convince myself that yes, what I'm doing right now is making sense to everybody. Okay? Somebody okay? Yes, Sahit. So Sahit, you're late by 10 minutes, but I promise you have not missed anything so far. Okay?
Yes, sir.
That doesn't mean that you can afford to be late. Try to be on time, but yeah. So for today, at least you have not missed anything. So only thing I have told so far is, we as a group will assume that ellipse is the source, and if I get a tailored version of ellipse, meaning when my major and minor radius both become same, that is when a circle is born. So that's the only conclusion we have drawn so far. Okay. So now it's time for us to look at the properties of ellipse. So when we talk about anything around geometry or shapes, the first and the foremost thing that we should focus on is, do we know each and everything about that shape or not? Because that happens to be the building block. Let's say if I'm talking about ellipse, if by any chance my ellipse looks like an egg, excuse me for that, but this is an ellipse. So what are the properties of ellipse that we know so far? And again, since we talked about it in the last class, that ellipse is coming from it's part of the conic section. So you had a cone like this, and you took a section like this. You took a knife and cut it with a slanted, with a slanted slide. And then if you see what is coming here is this ellipse. So that's why it's called conic section. So here, when I'm talking about ellipse, what are the things that we need to know? Obviously, as we discussed so far, you have one dimension along which it is wider or has more length. So this is called major axis. So from the center to the to the boundary of this along the major axis, this distance is called major radius. Similarly, along the y-axis, I mean, it's not that it's always bigger along the, it's kind of fat along the x-axis and thin along the y-axis. If wherever it is smaller in dimension, that axis is called minor axis. It could be x, it could be y, depending on how it is constructed. So this distance from the center to the boundary along the minor axis will be called minor radius. So if you go back to this formula of x squared by a squared plus y squared by b squared equal to 1, here this a, since this is big along the x-axis, horizontal axis, my a is the major radius in this case. It is small along the y-axis. This b is my minor radius, which is b here. Okay. I'm just trying to relate all these things. Okay. Now, what we are trying to understand is this is fine. So here to here, this distance is a, and this distance is b in this particular case. If I flip this ellipse this way, where it is thinner and taller, meaning my major axis is this one. Whether you call it A or B doesn't matter, whatever is your denominator of the y-axis in this case, that is your major radius. Does that make sense to everybody? Everybody okay so far? Okay.
Yeah.
So in this case, so we are just digesting or kind of acknowledging the properties that we know about. There's $1 million property, nobody gets $1 million though, of the ellipses. There are 2 points along the major radius or along the major axis, which has a very unique property and which is very, very, very specific to ellipse. Anybody recalls what those points are, or have you come across those points? Anybody? If you have heard it. Vishal, Samriddhi, Arush, Vijay, Achita, Dev, Sahib. Anybody? Read. There's something very unique about the ellipse. These 2 points, there are 2 points along the major axis. These are called focal points or focus points or foci. Yeah? And it comes with its own package of certain uniqueness. And that is, these 2 points are equidistant from either from the center or from the end point along that axis, along the major axis. So this distance and this distance are same. That is one property. Okay. And other property is, you pick any point, be it this point, be it this point, be it this point. Join this one and this one. Oops, where did I go? Join these 2 foci or focal points. Sum of this distance plus this distance will always be equal. Let's say this is D1 and this is D2. It will always be equal to 2 times the length of the major axis. So I know it's a lot of information. What it says is, foci are 2 points, 2 symmetric points along the major axis, such that these are equidistant from the end point along the axis, and if you pick any point along the perimeter and join these 2 foci with that point, the sum of the distance will always be equal to 2 times the major radius. Does it sound believable or coming as a new and very new concept? Arush, have you heard about this beta? Focii?
Not too much.
Okay. So now the summary of the story is ellipse has a very unique property where along the major radius or major axis there's a pair of points, pair of symmetric points which are like equidistant from the endpoints, and any point you pick on the perimeter and join these two foci with that point, sum of the distance will be equal to 2a. Okay. Now, if I say that, okay, memorize this, you guys will start hunting for a better teacher, and I don't want that to happen. Jokes apart, we are not going to believe it on its face value. We will try solving it. Okay. So let's first look at. So Praneeth, had you come across this foci thing before?
Yes, but I forgot about it.
Okay. I had forgotten about it too because I think I talked about it 3-4 months ago. I remember the property, but yeah. Let's try to find out. This guy is out of line. Let's try to find out why people say that d1 plus d2 equal to 2a. We'll try to find it out. And when I say d1 plus d2, I'm talking about this is your. Am I running out of markers? Okay. So this is my major axis, this is my minor axis, and by definition it says the 2 points. The only thing that you have to assume or believe is these 2 points are equidistant from the ends or from the origin. So let's first find out, let's say this distance is f, okay. We are trying to find out, first we'll come to find out this one later, okay. First we are trying to find out how far are the foci from the origin or from here. I mean, let's try to find out this focal length or distance of the focal point or the foci from the origin. Now, if you remember, this is my major axis. So this point's coordinates are a comma 0 minus a comma 0. This is 0 comma b, and this point is 0 comma minus b. Yeah. Vijay, am I reaching you well? Okay. Akshita, Dev, everybody okay? And that doesn't mean I'm not concerned about Samriddhi. Everybody okay, right? Okay. Alright. So here we are just visualizing this in the coordinate plane, and we are just told that these 2 points are symmetric points, meaning the distance from here to here and here to here will be the same. Okay. So let's assume that part is okay because that's the property. Okay. This is symmetric. So let's first find out how far is this point from origin. So what we can do is join this one. Now we have, this is O, origin, this is, let's say, P, and this is Q. So this is a right angle triangle for us. We are trying to find out this length. Okay. So this length is nothing but B, 0 to B. We are trying to find out how much is this one. Okay. So F will be equal to I'm just thinking which way to go. Shall I find out the focal length first, or shall I find out the, okay. Okay, fine. That's okay. Let's see. This, we are going with the Pythagorean theorem. This is, let's say this distance is d. Okay. So this distance f square plus b square equal to this distance square, d square. Okay. Now the question is, how much is this d? So if I join this point also, what am I seeing here? I am seeing that whatever this distance will be the same. Okay. This distance, let me give it a name, P O P Q, and let me give it a R. So this distance PR and this distance PQ will be same. Does that sound agreeable? Because these 2 points are symmetric, meaning this distance and this distance are same. This is common anyways, and this angle is 90 degrees. So if you apply the theorem of congruence, which is SAS, 2 sides and the angle between them. So this side and this side equal. This is common anyways, and both are 90 degrees. So these 2 sides will be the same. Yeah. Agreeable? No. Vishal? I am saying between this triangle, let's say this triangle, the one in red, and the triangle in green, I am saying these two triangles are congruent. Does that sound okay? Not okay. Okay. So what I'm trying to say here is that these 2 triangles are congruent because this side is common in both the triangles. This length and this length are same by the definition of foci, which says that these are symmetric points. So these 2 are same. So these two sides are matching between the 2 triangles, and this angle 90 degree, this angle 90 degree. So these 2 distances will be the same anyways. So this is D, so this is also D. Now this D, if we go by the definition of foci says these are 2 symmetric points which are such that if you pick up any point on the circle, on the perimeter of this one, and this distance will add up to 2a, 2 times the major radius. So that is what this one says. That is the property of that. So if these 2 are same, meaning D1 and D2 are same, so 2 times D2, 2 times this distance is equal to 2a, or D is equal to a. This is as per the definition, okay? And we are trying to figure out if this is, at least this one way to convince ourselves that this distance is, these 2 are adding up to be 2a, okay? We'll pick up one easy point, okay? One easy point. Let's say if we talk about this point, that means this distance from here to here and this distance from here to here should add up to become 2a. Am I okay? Let me go step by step. Let me do one thing. I think I should have changed my approach, because I'm myself not convinced when I'm explaining this to you guys. So let me go with the first approach. Okay, I have, so wipe off whatever I said like the way I wiped off the board. So this is the ellipse. Okay, we are trying to find out, these are 2 foci, focal points. Let's say this is P1 and P2, or F1, F2, okay? by definition it says the distance from here to here and here to here is same. That's the basic property. Is that okay to start with? So that is given. We are not going to try proving that. So it says any point along the perimeter of this ellipse, sum of the distance from this to that point. Let's say I'm picking up this extreme point, this one. We know this distance here to here is A. This distance here to here is B. Okay. So we are picking up this extreme point. Here this distance is A. So we are trying to add this one, the one in red here and the one in green here. These two are same because of the definition of the ellipse. Okay, it says that these are symmetric points, meaning the distance from perimeter to here will be the same. Okay, so this green distance and red distance are same. Now we are trying to find out, at least for this point, is this green distance plus the black distance, these two add up to be 2a or not? Because by definition it says d1 plus d2 is equal to 2a. We are just trying to convince ourselves. If we pick up this point, distance from this foci, which is the green one, and distance from this foci, which is this black one, does it add up to be 2a? And the answer is yes, because this and this are same. So if I'm trying to add this and this, I'm trying to add this plus this, which is 2a. So first situation is agreeable. Yeah? Is it only agreeable to some of you or everybody is fine? Arush, Vishal, Dev, Sahit. Okay, so we just picked up one situation and we tried measuring this distance from one foci to that point, and from this foci to that point, it's adding up to be 2a, because this here to here is a, here to here is a, this whole thing adds up to be 2a. So when we try adding this green and this black one, I'm essentially talking about adding this plus this, which is 2a. So one situation is done. So this looks convincing. Now, first situation is done. Now, if I come to this point and think about it, let's pick up a point. I'm just thinking, if I pick this point here, what will be this distance plus this distance? So if we try to find out this distance plus this distance. So one thing that we saw was this distance and this distance are same. I mean, it doesn't look like that, but it's because of my drawing skills. If I put the axis somewhere here, it will look more convincing. So this distance are same anyways that we saw before, right? Where we saw this line and this line and these two lines sides are same, and this is common. These both angles are 90 degrees, so these two are same. So we are trying to find out what is this length. Is this equal to a or not? Correct? We are just trying to figure it out. So this distance from here to here is b, and we are trying to see if this is a or not. Yeah? Any clue? How would you think about it? I have one thing in my mind, but before I go there, I want to see. You know this distance is b because this is a minor radius. Here to here it is a. That also you know. Now we are trying to find out if how do we get to point that this length is equal to A? If that is the case, then we will say this distance plus this distance, meaning the distance from this foci to this foci is adding up to be 2A. So if this is A, both are same, this will be 2A. Any thought? Praneeth, anything that you recall from the previous class? No? Arush, Akshita, Sahit, anybody? You are leaving your teacher all alone to struggle with this? Okay. So here's the thing. We can apply a lot of interesting concepts to find it out, but whatever we saw just now, okay? Whatever we saw just now, that taking extreme point here or here, okay? It says that any 2 point that you have which is symmetric in a way that the distance from any point to that point will add up to be 2A. Those are called foci. And we saw it happening in this case for the extreme cases, okay? We're not going to do for each and every point to find it out, because that will need little bit of, not little bit, more extensive knowledge of application of your calculus. So we are not going that far. So what we are saying is, we saw the extreme points and we are using that as a concept to agree to the fact that yes, that these two foci, distance from the two foci to that extreme point adds up to 2A. So that means here you are saying that this is A based on the corollary that we had seen with the extreme point here or here, and that is taken as a interpretation to relate and say, okay, fine. The sum of the two distance is 2A. So here in this case we saw that these two triangles are congruent. So these two distances will also be 2A, and hence these two distances are A. So keeping that in mind, the focal length from here to here, this is found by using the Pythagorean theorem, which says f square plus b square equal to a square, or f square will be equal to a square minus b square square root. So this is the focal distance, or the distance of the focal point from the origin. That is how this is related. Now you will say that, sir, you took a shortcut. And that is true. I took a shortcut because we are not going to stretch too much to figure out how do we convince ourselves that every point is 2A. We can find out some creative ways to find it out, but if you look at how this is proved, it's always seen as, first this is given as a property that, okay, foci are the 2 points that adds up to, distance from the foci to any point in the perimeter adds up to be 2A. And we just took one example, which is where it looks much more convincing, because it's much more relatable and easy to interpret. So we'll keep it simple that way so that we don't forget about it. But from that we have derived how far this foci is from the origin using this concept. Does it sound convincing or it doesn't? Akita looks okay. How about Sahit, Dev, Arush? So see what the takeaway is. One thing is, what is the foci that we need to be aware of? How is the distance from both the foci to any point on the perimeter is 2A. We just saw one example, taking the extreme case, because that was the easiest bet that we could go for. So to say, okay, fine, this is agreeable. And then we took that information to kind of make a conclusion that yes, this works, and then if that works, then the focal distance is equal to this. Now you will say, okay, fine, we can use the reverse of this for proving this. If I know this point, this is a square minus b square square root. So if I have to find out this length, that will be a square minus b square square root, square of the whole thing plus square of this whole thing will be equal to this length. So this adds up to this. So basically, even when the foci is derived or defined, it is derived as foci is always the square root of the difference of the squares of the two radiuses. So if this is taken as a concept, then you can find out this length, or else we will use this extreme points to agree to the fact that distance 1 from one foci plus distance 2 from second foci adds up to B2A. Yep. So this is the concept around foci. If I find something more interesting and easy to relate, I will let you guys know. If you find something before that, you guys let me know. So we'll use it for the benefit of the class. So now let's look at some problems that I have picked up that we wanted to practice today and see how that relates. I mean, how we can use our knowledge of ellipse for dealing with it. But before we do that, any questions? And some of you who were not in the class before, I will just touch upon one more thing real quick. If you look at circle equations, what we have seen is x square plus y square equal to r square, where r is the radius. If my circle moves to another point and my radius has the coordinates h comma k, my circle equation becomes h minus h square plus y minus k square equal to r square. Same way, if my ellipse is my minor and major axes are coinciding with the origin, then my equation of the ellipse becomes x squared by a squared plus y squared by b squared equal to 1. If my ellipse moves and goes here with the coordinates of the origin being h comma k, then my equation will change to x minus h square by a square, which is the major radius, plus y minus k square by b square equal to 1. So I'm just trying to show the correlation, how circle equation that we have seen versus how the ellipse equation will behave, so that we are able to relate to it, where a is nothing but the radius along the x-axis, b is nothing but the radius along the y-axis, whether it's a major axis or minor, while it's a major radius or a minor radius, that depends on the value that we see. So we will not go with any assumption that, okay, x minus h by square divided by major radius. No, we are not saying that. This radius is along this axis. This radius is along this axis. That is what we have to be careful about. Yeah? Sure? Everybody? Okay? So now let's look at some problems. And what I will do is, I will share my screen, because the problems that I have picked up, they have a lot of visuals to it. And if I try drawing it, I will end up wasting your entire time only me drawing those things, okay? So that's why let me save some time here, and I will rely more on you guys talking to me, meaning you have to unmute yourself and share, okay? Because when I log into WhatsApp on my this thing, I cannot see what you guys are showing me, or I am not going to see my screen, okay? Or I'm not going to see your responses. Just 1 second. All right. So, okay. Fine. So let me me share my screen real quick, and you guys can unmute yourself and respond to my question, because I will not be able to even see who has raised hand. Okay. Can you guys see my screen now? Okay. Now I cannot see anybody. So I am going to pre-calculus. Sorry. You guys see all my WhatsApp chats not needed. How do I open up my pre-calculus alone? Groups, okay. Pre-calculus, where is pre-calculus group? Man, I should have figured it out before. Pre-calculus. Yeah. Okay. Yeah, can you guys see the questions now? Somebody to unmute and say yes.
Yes.
Okay. So here is the first question. Okay. You guys are seeing some numbers. Ellipse is graph below. What is the center? Choose one answer. Okay. So this will not make any sense to you guys unless you see this picture. Okay. So take a note of what you are seeing here. In your notebook, you can see where the center is, what a potential, what could be the major minor radius lengths in units. Take a note of it. Okay. Then we'll go back to the questions. And I know it sounds funny when you see that your teacher is struggling with dealing with WhatsApp. So I'm not an expert. I just use WhatsApp for chat. So when I open it here, I was kind of struggling. But anyways, this will save some time for us. So you see these points, okay? Where the center is, how big the major and minor radiuses are, okay? I'm hoping that you guys have taken you can take a picture of this in your phone if you want to, okay? And let me go back to the questions. What is its center? Which one you think is the center? A, B, C, D. So just to,
I think it's A.
it's A.
Yeah.
I think it's A.
Yeah. So my center is here, right? This point where you see the cursor, which is -3, -2. So -3, -2. -3, -2. Sorry, my bad. I'm not reading it keeping the x and y axis. So my x coordinate is -2 and my y coordinate is -3. So you guys are right. Yep. Now let's look at the second one. It says what is its minor radius or semi-minor axis. So minor radius and semi-minor axis are the same thing. Okay? What do you think? Which one? A, B, C, D? Take the picture again. Look at the picture again. If that helps. Semi-minor axis or minor radius. This is your minor radius. This is 1. Whichever is smaller, that is your minor radius. Okay. So you will not go by x or y. You will go by this distance, which is small. So that is from -2 to -1.5. So that would be 0.5 units. No, it's D. No, it's D with her.
Oh yeah, divide.
Oh, D.
Yeah. Same thing. Now, what is major radius or semi-major axis? Same thing. Semi-major axis is from here to here, right? So it's going from minus half going till 3, so 1.5 units, correct? Whichever you see here, D unit. Yeah? Are you guys with me, or I'm getting you guys bored and tired? I cannot see my screen right now, so I don't know if you guys are enjoying it or you're getting bored. Okay. So see, emojis will not work. When I go to WhatsApp, I can not see my screen. I cannot see the screen that I'm seeing right now. So that's why I would lean on you guys responding to me to be able to make more sense. Okay. Now let's go to the next question. It says an ellipse is graph below. What is its center? Choose one answer. This is the ellipse. What is its center? You guys have seen the ellipse. I will go quickly here. What is the center? D. Yeah, no questions, right? You guys see it's here at the origin. Let's go to the next question. Now, this is interesting. You have the equation of the ellipse here, x minus 8 squared by 49 plus y minus 2 squared by 9 equal to 1. Tell me what is the center and what is its major radius in units. Anybody? These are like easy pickings, okay? This kind of question when you get in the test, it should be like 20-second question, okay?
The major radius is 7.
Okay.
The center is 8 by 2.
8 by 2.
Yeah.
8 comma 2.
Yeah.
Yeah? Where this is your h part, how much it has moved. X minus h squared by y minus k squared, right? So this is your, I'm sorry, bro?
No, yeah, that was what I was saying.
Yeah. Everybody agrees to what Pranit said, or you guys have a different point of view? Arush, Akshita, Samriddhi, you guys okay? Vijay? See, I told you guys, I cannot see the screen. You have to talk to me. Talk to your teacher, okay? Okay, let's go to the next one. Now this time, it should not be Pranit. I want every child to talk. So, the equation of an ellipse is given below. What is the center and what is the major radius? And I'm not prohibiting Pranit from answering it, but I certainly want everybody to participate. Sahit, what do you think, Uta? Sahit, Arush, Samriddhi, Akshita.
Is it center -5, -7? Or -7, -5?
-7, -5, yes. How about the major radius?
A 4.
Yeah. So here, when you see a plus sign, your default equation is x minus h squared by a squared plus y minus k squared by b squared equal to 1. Where h and k are assumed to be positive values. If it moves here, your h will remain positive, but your k will become negative. So this will become y plus some number. So depending on where your center has moved, you have to be careful about it. But the default is h and k, where h and k are both supposed to be positive. So if any of them changes, you'll have to just carefully look at it. If it's giving us +7, that means there's a negative, it's in the negative quadrant of x. So that is basically now moving to the second quadrant. Similarly, y is also negative. So that is this is your quadrant where both the values are. So your center has moved to the third quadrant actually. Yeah? Are you guys able to visualize that part?
Yeah.
Yeah? Okay. Now, so now this is a riddle, okay? This will this will check your memory and your visualization skills together. We have 4 options here, okay? We have an equation here. You can probably note down the equation, okay? And when I slide through all the options, then you can try recalling it. Your equation is x. Okay, let me do one thing, just for the benefit of everybody. Though I cannot see anything, but you guys can certainly see me and the board. So I will write the equation for everybody's benefit here. This is x minus 4 square divided by 16 plus y minus 1 square divided by 49 equal to 11. Is it 11? No, sorry, 1. Okay, this is the equation. So I have put the equation here and you guys can see the first option on the screen right now. Is that okay? Is that one of the options? Does A look like an option for this, which is representing this ellipse? Anybody?
No.
No? Simple, right? My x value is negative. That means my h is a positive value. It cannot be in the third quadrant or second quadrant. So this is ruled out. Next one. How about this? I'll still rule out. First one, the way we ruled out, right? My x value is positive, right? X minus 4. Minus 4, that means it has to be in the first or fourth quadrant only. Second, third quadrants are ruled out. So I'm eliminating this one right away. Yeah? This one also eliminated. It cannot be the case. See? Now we are trying to check. Now this is the only option which is looking legitimate. So x minus 4. So this is in the, my x value is positive. I mean center's x coordinate is positive. Center's y coordinate is also positive. And this looks to be right. Yeah? So again, for these kind of problems, right? See, what will be a dirty technique? As soon as you saw this one, your first interpretation is my center's x coordinate and y coordinate both are positive. So it cannot be here in this region. This one, as soon as you realize first one is not an option and second one also in the same area, rule it out, move on. Done. Yeah? So this is where that excitement or that correlation that you will draw from your own interpretation will help you solve things much faster. Yeah? Does it sound okay?
Yeah.
So all the playful things that we do, that is the only thing that will stay with us. Everything else serious that you do, you might end up forgetting. So my request to you all is always to find out some playful opportunities, okay, while doing math. Because I feel at least 10 years younger when I'm dealing with you guys. So I'm kind of 40 right now. Once the class is over, I'm back to 50. Okay? So I want you guys to explore that element of excitement when you're doing math. So just to do a quick recap. So I don't want to do that recap today. I want one of you to do the recap. Who will take a chance? It's okay. I want to hear back from you guys what all did we do today. Let's see if somebody is able to summarize that. Because this is something that you will end up doing for the rest of your life. Be it in school, be it in college, they'll say, okay, present what you know. So whatever we have learned, let's see what all you are able to recall and talk through. Anybody? Nobody? Akshita? Arush, anybody? Vishal? See, Vijay, I mean basically I'm just wanting somebody to summarize, say, okay, what all did we learn today? Okay? Not better, not that way. You can type it, but I want somebody to narrate it. I want each one of you to become as fearless as possible. Because the element of fear is what pulls us back. I want each one of you to become, not like six-pack child, but confident enough to talk about things. That's okay. I get it better. Anybody who wants to show that fearless aspect. Praneet, you want to give it a try? I just want somebody to summarize what did we do today.
So we looked at one of the conic sections, the ellipse, and we saw that in the ellipse there is a certain point called a focal, and where from there you can, like, the choosing point on the perimeter, when you add up the lines, you get to 2a, and then
So that was a good attempt. So I'll just add a little bit color to it. So basically what we did was we first wrapped our head around what is conic section, which you rightly said, and how is ellipse one of the conic sections, and then we tried relating circle and ellipse, where we said that okay, basically ellipse is the more generic shape, and circle is one flavor of it. When both your major and minor radius become same, that is when circle is born. And that is how we tried relating circle equation and the ellipse equations. Okay? In the previous class also we had seen, okay, if my ellipse equation is x squared by a squared plus y squared by b squared equal to 1, when my both the radiuses become same, a and b both are same, and that becomes r, that is how it becomes x squared by r squared plus y squared by r squared equal to 1, and that gives birth to x squared plus y squared equal to r squared equation. So circle is derived from ellipse. That was our first point. And then we looked at what is foci. So foci is more of a very unique behavior or property of ellipse, which is like a pair of points along the major axis, which are symmetric in nature, meaning it is equidistant from the endpoints or from the origin, such that any point you take on the perimeter of the ellipse and join both the foci with that point, the sum of the distance will always be 2a, meaning the foci is a pair of points which is equidistant from, sum of the distance is same regardless of which point you are picking up along the perimeter of the ellipse. And we just looked at how do you find out the length of the foci, which is square root of a square minus b square. A is the major radius and b is the minor radius. And remember this, that a and b in the equation is always, a is the major radius, b is the minor, sorry. When you look at the equation x squared by a squared plus y squared by b squared, a and b are the radiuses along the x and y axis. Wherein when you are looking at the foci, you are very, very clear about the point that foci is only along the major axis. Whether the major axis is along A or B, doesn't matter. You will find your foci as square root of difference of the major radius minus minor radius square. So if your ellipse is like this, then this equation will change to b square minus a square. Okay, and it's a logical point also, because see, if your major radius is this one, then difference of that will give a negative value. You're talking about imaginary solution for this. and foci is not imaginary, it's real. So it's always a difference of median radius square minus minor radius square. Yeah. So that was a quick summary of what we did today. We are already over by 2 minutes. So I will let you guys go. Enjoy the rest of the evening. Have a good dinner and good night sleep. See you in next class.
Bye.
Bye bye.
Bye.
Bye.